Welcome to the Deep Dive. We got a really interesting paper sent in about this new benchmark called BoxingGym,
Okay.
and it's designed to kind of push the limits of what AI can do in scientific discovery.
Yeah.
And it looks like what really stood out to the person who sent it in was the methods, like how they're actually testing these AI scientists,
Right.
and then what those initial results are telling us.
Yeah, it seems like they're really interested in the nuts and bolts of how this all works.
Right.
Not so much the larger implications just yet.
Yeah, exactly.
More the mechanics of it.
Okay, so let's unpack this.
Okay.
The paper focuses on two core AI skills.
Mm-hmm.
Experimental design, which is choosing the right experiments to run,
Right.
and then model discovery, where the AI has to build explanations based on the data.
Yeah,
It's really like a roco scientist, huh?
precisely. And to make that work, the creators of BoxingGym have actually simulated these scientific worlds as computer programs.
Wow.
So these AI agents can run these virtual experiments.
So they're not dealing with real-world data just yet,
Not yet.
but working within these controlled virtual environments.
Exactly.
Tell me more about those environments.
Okay.
What kind of scientific problems are these AIs tackling?
So they've created 10 different environments,
Okay,
and each is drawn from a real scientific field.
got it.
For example, there's one environment that involves predicting signal sources.
Oh, interesting.
That's straight out of physics.
Yeah.
Another one tries to figure out how people value money over time, which is a classic problem in psychology.
Okay, so there's a real variety in the types of scientific thinking that they're testing.
Yeah,
It's not just about, can an AI do physics, can an AI do psychology,
right.
but can it adapt its approach to different fields?
Exactly.
What were some of the other environments?
Let's see.
Yeah.
They also had one that modeled how a disease spreads, which falls under epidemiology.
Okay.
And they even had one that simulates a classic psychology experiment called the death process, where you're trying to model how something spreads through a population, kind of like a rumor on social media.
It's like a scientific buffet.
Yeah.
They really threw the kitchen sink at these AI agents.
Yeah, they wanted to see what they could do.
Okay, so we've got these virtual environments, we've got these AI agents running experiments.
Right.
How do they actually judge how well these AI scientists are doing?
That's a great question. It's
Yeah.
not like they can give them a lab report to grade, right?
Right, exactly.
So they really focused on those two core skills that we mentioned earlier. Experimental design and model discovery. For experimental design, they use something called expected information gain, or EIG for short.
EIG. Okay, now we're getting into the nitty-gritty.
Yeah.
Can you break down EIG for me?
Sure. So imagine you're running an experiment.
Okay.
EIG essentially measures how much information you expect to gain from that experiment.
Yeah.
It's about choosing experiments that will give you the most bang for your buck,
Got it.
so to speak.
So it's not just about doing experiments, it's about being strategic and choosing the ones that give you the most valuable information.
Exactly.
Okay.
So a higher EIG means a more informative experiment.
Got it.
And to assess the AI's performance, they compared the AI's EIG to what you would get by just randomly choosing experiments.
Okay.
So if the AI's EIG is much higher,
Right.
it means they're actually being thoughtful about their experimental choices.
Interesting. So they have a baseline for comparison.
Right.
What about model discovery?
Okay, so model discovery is where it gets really interesting.
Okay.
They evaluate it in a very novel way.
Okay.
The AI has to write an explanation of its findings
Okay.
that a second novice AI can understand and use
Interesting.
to make predictions about the virtual world.
So it's like the AI is teaching what it's learned to a student.
Precisely.
Okay.
It has to articulate its knowledge
Yeah.
in a way that another AI can understand and use. And this tests whether the AI truly understands something, not just memorizing patterns in the data.
That's a clever approach.
Oh.
Okay, so we've got the testing ground, we've got the evaluation methods.
Right.
What kind of AI agents did they actually put to the test in BoxingGym?
So they tested two main types.
Good.
First, there's the pure language model. Think of it like a really advanced chatbot.
Okay.
And then they had what they call a more statistically minded agent,
Right.
which they called Box's Apprentice,
Okay.
which can write and use statistical models in addition to its language capabilities.
So one's more language focused and the other has a statistical toolkit.
Exactly.
It seems like the Box's Apprentice would have a clear advantage in a scientific setting.
You'd think so, right?
Yeah.
But the results were actually quite surprising.
Really?
While both agents struggled with the challenges,
Okay.
the pure language model did surprisingly well in some cases.
Really? I wouldn't have expected that.
Yeah.
So even without being specifically trained on statistics,
Right.
the language model could still pick up on some of the scientific concepts.
That's right. It seems that current language models have this unexpected power when it comes to understanding and reasoning about certain scientific concepts,
Yeah.
even without that explicit statistical training.
Okay, now I need specifics.
Oh,
Give me some examples of where these AIs shined or maybe face planted.
All right, let's dive into the results.
All right.
One example that stood out was in the hyperbolic temporal discounting task.
Okay.
This is all about how people choose between getting a smaller reward now or a larger reward later.
Okay.
Like the classic marshmallow experiment.
Oh, so testing the AI's understanding of delayed gratification.
Exactly.
Okay.
The language model was initially quite good at predicting human choices in this task, even better than the box's apprentice.
Wow.
But then, after running experiments and getting more data, its performance actually got worse.
Wait, what? More data usually means better predictions.
You'd think so.
Yeah.
But in this case, it seems like the language model got a bit overconfident and started overfitting to the specifics of its limited experimental results.
Got it.
It got too focused on the small details and missed the bigger picture.
Fascinating. So even though it had an initial grasp of the concept, it couldn't quite handle the nuances of the new data.
That's right.
Yeah.
And this highlights an important challenge for these AI agents.
Okay.
How to balance that prior knowledge with new data.
Yeah.
Especially when that data is limited.
It sounds like they're still learning to think like true scientists.
Yeah, exactly.
What other interesting findings came out of these BoxingGym experiments?
Well, another interesting observation came from the location finding environment.
Okay.
Where the goal is to pinpoint the location of hidden signal sources.
So spatial reasoning and data analysis all in one. I'm guessing the statistically minded Box's apprentice excelled here.
Well, that's where it gets interesting. Box's apprentice, despite having those statistical tools, actually struggled quite a bit with this task.
Right.
It had trouble effectively using the data it collected to refine its estimates of those source locations.
So even though it could run the experiments and crunch the numbers, it wasn't quite grasping the underlying spatial relationships.
That's the gist of it. So this highlights that statistical modeling alone isn't enough.
Right.
You need to have the right kind of reasoning abilities to make sense of that data.
Yeah.
It's like having a fancy calculator, but not knowing the right formula to plug in.
I see.
Right.
So these AI agents are showing us that being a scientist is about more than just crunching numbers or being good at language. There's a deeper level of understanding and reasoning involved.
Exactly.
What other challenges did they face?
Let's talk about the IRT environment.
Okay.
This one deals with modeling student performance on tests.
Okay.
Trying to figure out who's likely to answer which questions correctly in this environment.
Yeah.
Something really intriguing happened.
Okay, I'm hooked. Tell me more.
The language model, when it was forced to explain its findings to that novice AI, actually performed better than when it was just making predictions on its own.
So explaining things out loud made it smarter?
It seems counterintuitive, right?
Yeah.
But by having to articulate its reasoning and make it understandable to another AI, it seems like the language model kind of solidified its own understanding.
It's like when you teach someone else something.
Exactly.
It forces you to really think it through.
Yeah.
And understand it at a deeper level.
Exactly. It suggests there's a lot of potential in using these communication-based approaches to improve AI learning and reasoning.
That opens up a whole new avenue for AI development.
Yeah.
Did they notice this effect in any other environments?
Well, in the moral machine environment, they didn't specifically look at the impact of explanation.
Right.
But this environment itself is incredibly interesting.
Okay.
It's based on a project that explores people's moral intuitions about self-driving cars. You know those classic thought experiments? Like if the car has to swerve, should it hit the grandma or the child?
Yeah, the trolley problem, right?
Exactly.
Always a tough one.
Yeah.
So how did they test the AI's moral reasoning?
So in this environment, the AI had to predict how humans would make those tough moral decisions based on factors like age, gender, social status.
So it's not just about cold, hard logic.
Right.
but about understanding human values and behavior.
Exactly.
That's a complex task for an AI.
It is.
How'd they do?
Both AI agents struggled with this environment.
Okay.
Which isn't surprising given the nuances of human moral judgments.
Right.
The results show that even the most advanced AI systems
Yeah.
still have a long way to go in terms of understanding human values and ethics.
It's a good reminder that while these AI agents are showing promising abilities,
Right.
they're still in the early stages of development.
Yeah.
Okay, so we've got these diverse environments, clever evaluation methods. What surprised you the most about the results overall?
One of the biggest surprises was just how well the language model performed, especially in tasks that you'd think would require a strong statistical background. Yeah. So it really challenges the assumption that AI needs to be explicitly programmed with that statistical knowledge to do well in science.
So there might be more to language understanding than we initially thought.
Yeah.
At least in terms of its potential in science.
Exactly. It seems like these language models are picking up on more than just patterns in the data.
Right.
They're somehow grasping those underlying concepts.
Yeah.
Even without that explicit training.
That's both exciting and a little unsettling, right?
Absolutely. It raises all sorts of questions about the nature of intelligence and how we evaluate it.
Okay, so we talked about the environments, the agents, the surprises.
Right.
What about the methods they use to evaluate these AI scientists?
Okay.
How did they actually grade these robo-scientists?
That's an important point. They used a combination of quantitative and qualitative methods to kind of get a holistic picture.
Got it.
Remember, expected information gain, EIG?
Yeah.
That was a key quantitative metric.
Okay.
They used it to compare the AI's experimental choices to an optimal strategy.
So they had a benchmark.
Right.
To see how strategic the AIs were being.
Exactly.
What about the qualitative side?
Okay.
How do you judge something as subjective as scientific reasoning?
For that, they looked at how well the AI agents could explain their findings to that novice AI.
Right.
If the novice AI could learn from the explanation and make accurate predictions.
Yeah.
That suggests that the first AI had a good grasp of those concepts.
So it's about more than just getting the right answer.
Right.
It's about being able to communicate those findings effectively.
Precisely. They also looked at the AI's outputs directly, the actual models that they created, and compared those to the ground truth models underlying the simulated environments.
So kind of like checking their work to see how accurate their models were.
Exactly. In some cases, the AIs came up with models that were surprisingly close to the ground truth, showing they can extract meaningful patterns from the data.
Okay.
But they also noticed areas where the AIs struggled, which kind of highlighted where future research might be needed.
It sounds like this BoxingGym benchmark is providing some valuable insights into both the capabilities and the limitations of current AI systems when it comes to scientific discovery.
Absolutely. It's a powerful tool for evaluating and comparing different approaches to AI.
Yeah.
Helping us understand what works, what doesn't, and where we need to go next.
We've covered a lot of ground here.
Yeah.
And I'm starting to get a real sense of how this BoxingGym works and what they learned.
It's been quite a deep dive into the methods and results of this paper.
Indeed.
Yeah.
But no research is perfect.
Right.
And I'm curious about the limitations of this study.
Sure.
What caveats did the researchers highlight?
One of the main limitations was that these are all simulated environments. Right. Simplified versions of the real world.
It's not like these AIs are out in the field collecting data or running experiments in a real lab.
Exactly. So while these simulated environments are a great testing ground, we have to be cautious about how much these results will actually translate to those real-world scientific settings.
It's like the difference between practicing your driving skills in a video game.
Yeah.
And actually getting behind the wheel.
A great analogy.
What other limitations did they mention?
They also highlighted that they only focus on a small set of AI agents. Okay. A pure language model and that statistically minded agent. Yeah. But there's a whole world of different AI approaches out there that they didn't test.
Makes you wonder how other types of AI agents would perform on these BoxingGym challenges.
Yeah.
Could reveal different strengths and weaknesses.
Right.
Give us a more complete picture of how AI approaches scientific thinking.
Absolutely. So while this research gives us a fascinating snapshot,
Yeah.
it's important to remember it's just one piece of the puzzle.
It seems like we're still in the early days
Yeah,
of figuring out how AI can contribute to scientific discovery.
definitely.
This BoxingGym benchmark is a valuable step in that direction.
Yeah.
But there's still so much more to explore,
So much more.
even with these limitations in mind.
Yeah.
I'm curious, what stood out to you as the most important takeaways from this research?
Okay.
What did you find particularly interesting?
For me, it was how adaptable these AI agents were
Okay.
across all these different scientific domains,
Yeah.
from physics to psychology to ethics.
It's true.
They were able to tackle a really diverse set of challenges.
They're like scientific jacks of all trades.
Exactly. And while they're not experts in any one area yet,
Right.
that adaptability points to AI's vast potential to contribute to science in ways we haven't even considered yet.
Like, they're giving us a glimpse into the future of scientific research,
Yeah.
where AI helps us connect different fields and uncover new knowledge.
Exactly.
That's a really exciting prospect.
It is.
And it gets back to what we talked about earlier, the importance of collaboration.
Right.
It seems pretty clear that AI won't be replacing scientists anytime soon.
Definitely not. But it points to a future where AI and human scientists work together,
Right.
each bringing their own strengths to the table.
Yeah.
It's not about AI versus humans.
Right.
It's about AI and humans working together to push the boundaries of scientific discovery.
A partnership with the potential to unlock incredible new insights. I like that.
Yeah.
We've dug deep into the methods, the results, the limitations.
Well, I have.
Any final thoughts for our listener as they delve deeper into the world of AI and science?
You know, as I've reflected on this research, one thing keeps coming back to me.
Okay.
This research is a powerful reminder that science is, at its core, a process of exploration and discovery.
It's about asking questions,
Right.
testing ideas,
Yeah.
and always striving to deepen our understanding of the world.
Exactly.
It's a journey that requires curiosity, creativity, and a willingness to embrace the unknown, qualities that are essential for any scientist,
Absolutely.
whether they're working with AI or not.
Absolutely. And I think that's a great note to end on.
Yeah.
This BoxingGym research gives us a glimpse into the exciting possibilities of AI-powered science.
Right.
But it also reminds us that the heart of science lies in that human drive to explore, to question, to discover.
And on that note, we'll leave you to contemplate the possibilities.
Sounds good.
Thanks for joining us on this deep dive
Yeah, thanks for having me.
into the world of AI and scientific discovery.